Hello, my name is Peter Lewis. I'm a software solutions architect in Cisco CX, and I work in the automation space and obviously heavily deal with NSO and NSO projects. I've been working with a large enterprise customer for the last couple of years, but previously working with quite a few different varied customers over the SP and the enterprise domain. So today, what I want to talk about is our example of one of our customers that we've worked with, where we've rapidly adopted NFV services using the NSO automation framework. So the key question that we're going to try and answer to you today is all about the rapid deployment of new services, and is it viable to have automation for services for new service patterns that are only used infrequently or even once? So is it viable to automate all that if you're only ever going to use that service once? So a couple of questions about some important facts about enterprise customers, because we're looking at this from an enterprise point of view. As you can imagine, it's a more common scenario than for an SP. So a bit of research, we can see that Forbes have spoken to a lot of enterprise customers, and they came up with some important points about the journey that our enterprise customers are on, their digital technology journeys. And they've often said in response to the questions that one of the biggest challenges they face is obviously resistance to change. Companies like to stick with what they know, I guess, and resist those sorts of new technologies. But I think the companies also realize that they need to change. So they want to adopt new technologies, but integrating them into their existing systems is very difficult. I think one of the biggest reasons for that is that the internal resources that they have to provide those new skills are low. They don't have massive IT organizations with lots of people with new skills, and they know all the latest information. I think a lot of times they lack those skills that these transformations require. So obviously the enterprise do want to invest in technologies that really do focus on reducing their operating costs and increasing their efficiencies, as all good businesses do. So where does that leave us with enterprise customers? Well, I guess that one of the ways that you can reduce your cost is trying to standardize your business, trying to fit everything into a one-size-fits-all sort of model. But again, with enterprise customers, that's quite difficult because IT infrastructures can vary quite greatly across your organization. Sometimes enterprises are made up of different acquisitions that all have all the different IT systems, so they're very disparate and sometimes hard to standardize those models. Obviously, different business units have different needs, different business needs as well. So that impacts how they use the IT systems. And often the IT teams, the IT teams don't have as much sway. They don't have as much power in the enterprise teams because the business is driven from whatever that enterprise customer is doing, whether they be a bank or a manufacturer. The main business is always going to be those, and the IT is there to help them. So they might not have as much power to push those teams to standardize what they're asking for. So these are some of the challenges, and obviously all these different business units within the customer want quick time to markets and high return on investments, obviously. So I guess back to our initial question about services that are used infrequently. A lot of IT teams will fall back to the classic, if it's not going to be used again and again, let's just do it manually. Let's, just do it this once. Next time maybe we'll look at doing it better or finding a different way. So often it goes down this route of doing things manually. And obviously when you do things manually, humans are doing things, they're typing in config, they're trying to allocate resources from spreadsheets or IPAM tools, who knows how they're doing this, but it's very hard to standardize that because suddenly you have a carte blanche to do anything they want. So it always leads to errors. It leads to errors. It's also then difficult to manage things like resource allocations that we just talked about, IPs, VLANs, things like that. Even when you do get that service spun up, you've got everything configured, trying to operationally deal with that service afterwards is going to be more difficult because you don't really know. You haven't got one central place that tells you about that service. So things like reporting is very hard. You've just spun something up, but you don't really know a lot of detail about it. So yeah, manually, of course, it has its benefits that maybe you can do it quicker, but it also does lead to some significant issues. So of course, we're here at the NSO Developer Days. We want to automate stuff, right? It's the logical path here. But as we're all probably aware of, automation still needs setup for each service pattern. So every time you want to create a new service, there's a life cycle you have to go through. You have to design things, make sure you get that sign off with the business unit or whoever your customer is. There's a development process, for developing the service models, for developing the templates that are needed, for the configurations, defining use case testing use cases, then obviously releasing that, and then finally going into that maintenance afterwards. So there's always an overhead with these services. Generally, from our experiences, an automation lifecycle can look something like this, where you have quite a long, drawn-out sort of process of working with your customer, trying to narrow down your requirements, kind of write all that down, get that signed off, creating some designs and maybe some topologies for them to review again to make sure that what those requirements mapped correctly into the design that you've written. Then we move it into a development phase where we're writing the service models, we're coding the templates. We then maybe validate that in our test environment, debugging it, go through some cycles, and then finally we're transferring that to live and then maybe running through the same process again with some acceptance testing in the live. So as you can see, that they can take weeks to deliver that pattern, those services to your sort of production environment. So what do we see as some of the historical issues with some of these enterprise customers and some of the requirements that they have to deal with in the IT teams? Well, typically we see that the services that they require are sometimes quite monolithic, quite very detailed, very specific, highly specialized for the purpose that they're going to be used for within that business. So they're not standardized. They've not thought about reusability as much. This then means that there's going to be some knock-on effects, right? So there's going to be a significant time to gather those requirements, to develop it, to test it, and to deploy that new service pattern. That obviously means costs are going to be high to develop that pattern and that service. So if it's only ever going to be used once or twice on a small scale, then it's obviously prohibitive to automate it. Again, quality is another issue that the more specialized and sort of manual steps are required for the development of a service, it can lead to the quality going down because every single service pattern is developed differently. So we see that the quality isn't as good, and it also has a knock-on effect with changes. If you want to, a couple of months down the line, make an update to one of those patterns that you had spun up, those services you had spun up, it can lead to a significant, effort to make a minor change to it, because you have to understand that pattern again, and yeah, it's not standardized. So ideally, we're looking to progress to a point where we have to sort of narrow our scope with these smaller patterns, these smaller uptake of patterns. So where we're only going to spin up a pattern once, we really do have to narrow the scope. So we want to simplify the automation as much as possible, so that we're only automating things that are repeatable. So we're making the patterns more easy to be reused. We're pushing out anything that is very specific to the pattern, very specific to that service. We want to push that sort of stuff out to a day 2 model. So we want to split the services up from perhaps a day 01, where we're just getting the services up and running with the core configuration applied to it. We're then pushing day 2 services out to any sort of specialized route maps or policies that we're going to apply on top of that service. We're pushing that out to a day 2 model. So we can automate that day 2, or we can do it manually. But the key is to narrow down the scope. Also, we want to introduce new tools to reduce things like requirements gathering, development, test, and deployment. Ideally, this will have a knock-on effect. It will reduce the time to deliver those patterns and services. So it means that it becomes very cheap to create a new service, which is ideally what we want for something that's only ever going to be used once or twice. If you introduce more automation in those processes, so we're going to look into some of those tools we're going to introduce, there's less manual work, and it also means that the costs are going to go down, but the quality is going to go up. The less you have to do manually, it means that that you can reuse things that are well defined and well tested. It means your quality goes up. And also for things like changes, the automation tool is going to provide a simple way to do that. So that's our where do we want to move to with these services. So one of the technologies that a lot of enterprise customers are utilizing and want to take advantage of is NFV, is virtualizing our physical equipment that we've got. It's all about reducing the capex and the opex of our services. When we virtualize things, we can spin up new network functions quite easily. In enterprise customer, we see it used at branch sites quite a lot now, and also on the customer's edge of the network. So that's the edge of the network is what we're going to be focusing on with our customer example, our customer success story. So what is an edge service? Well, an edge service is something that resides in our data center, in our private data centers within our customers, and they connect the campus networks, so the internal intranet networks, to perhaps a cloud connection, or just straight to the internet, or maybe to some extranet networks. So it's all about that interconnection between your campus and your external world. These edge services are made up of virtual network functions, which are hosted on some virtual management systems, OpenStack, things like that. So we won't get into too much detail about the actual technical aspect of the services, but just to give you an overview of what these services look like. So yeah, we can. This is a good example of a service that we've spun up in our customer. So what we have here is a campus at the bottom, our internal customer network that goes all the way out to some AWS cloud platform. And to do this, it needs to navigate through some physical equipment, so some hardware, some ASR routers, some Nexus switches, and some firepower firewalls. So there's some physical layers at the north and the south end of the pattern. And then in the middle is where we have this virtualization layer where we're using NFV. And here we're spinning up some Cisco virtual CSRs, some F5 WAF, some FortiGate firewalls. So a sort of mixture, multi-domain, multi-vendor DNS. They're all spun up on some OpenStack equipment. So that's essentially the services that we're looking at. A good example of an edge service within an enterprise customer. So obviously we're using NSO and NFVO to spin up these services. NSO, obviously, we all know about NSO. That's why we're at the developer days. But NFVO is a function pack that's built on top of NSO that helps us spin up these virtualized network functions. So the NFVO package is all based on an XPS standard, which is an industry standardization that helps us to model the network services. So that diagram, that service model I was showing earlier, can be described within an NSD. And that NSD is defined within these function packs, and it allows us to create services and simplify the automation of these services. So what does an NSD look like? So I've taken a very simple example. So the first sort of service model we looked at obviously was very complicated. There's lots of elements, but let's just sort of narrow it down to the basics of what an NSD is. So here we have a physical ASA, a physical firewall, a physical network function device, a PNFD, and we're spinning up a virtual network function, a CSR, a virtual CSR, and that's it. We have an internet connection to a firewall, an inside connection then to the CSR, and then we're off to a private network. So the NSD describes each of those elements separately. So it'll have a PNFD section, describe that physical device and how we're going to be using that in this service. And this will describe the interfaces. For example, so there's an internet connection coming into the firewall, there's a management interface, and then also we have a sort of southbound interface to our virtual equipment. Similarly, the VNFD will describe that we're spinning up a CSR, and that will define those virtual interfaces, the VNICs, so the virtual management interface, and also the northbound connection to the ASA. So these are all defined as virtual networks. So three elements to an NSD, three main elements to it. There's a physical network function, a virtual network function, and a virtual network to connect all those things together. All this NFVO is obviously built on top of NSO's data model driven approach. So it really is a very tight link. We have this XPS standardization of an NFV model with NSD, and all that is easy to map into NSO because an NSO is a data model driven product. It's a data model driven system. So we can have a central store for NSDs within the database, so a central store for our definitions. When we spin up services, we'll have a central store for the instances of those services, so the NS infos they're called. And then also we have details of the device model. So when those services are applied to the network and those devices are spun up, we also have a model for the devices as well. So it's all there inside NSO. And that's very key to understand here that the data model in NSO gives us all those elements, and they're all standardized to this XPS standards as well. I'm not going to go into too much more detail of NFVO and NSO. There's some links in the presentation here to some more presentations done with Cisco Live in the past, so you can look into those at a different time. So that's NSO and NFVO and how it fits and how enterprise could use these tools to help their businesses define patterns and new services. So what are the problems? Okay, so we talked about a typical edge service that the customer might use, and they could define that quite easily within the packages and spin that service up, and we'd be we'd be good. Problem is there's always going to be variance. So as we talked about earlier, the customer can't always quite standardize what they're looking for. So there always tends to be, something they want to add on, to that patent, perhaps, for a different usage. So they might need a new patent that has some pre-production. So there was the first one was a production, second one was a pre-production. They might want to test a test pattern where that doesn't go to the internet, it just stays internally within the networks. This can all then be duplicated because you have single DC instances, if it maybe one dual DC instance, so you have resiliency across data centers. You may then add some shared services onto the side of that pattern, so suddenly you have a lot more variances. And then finally, you might also have some OCSP interface and no OCSP interfaces, so it can get quite large sort of variances of what is needed. So what we're seeing is in enterprise customers that perhaps in what we ideally like to see is that maybe it's a complex pattern, very specialized pattern, and it's used many times, spun up many times. So the investment we put into that pattern development, that service pattern development, is paid off because we have many instances of it. But that's not what we see. We don't see that. We see the requirements of multiple different patterns because they can't quite standardize what you need. So there's so many different variances, and they may only have one instance of that pattern. So that's key. That's what we need to try and solve an issue for, because we can't spend massive amounts of time on the life cycle of those patterns anymore. We need to transition to a point where we need to be able to handle this type of model. So how do we do that? Well, we have NSO and NFVO, and they're great. They allow us to to spin up patterns. So I like to explain it as a cookie cutter. So the NSD, the NFVO package helps us define a cookie cutter, a sort of template. So, and then NSO on top of that, you can print out as many cookies as you want. So, great. NSO gives us those tools. Brilliant. No issues there. That's what it's great at doing. So now we need to look at some tools that can go on top of NSO. So tools on top of tools that can help us with the creation of those cookie cutters, because that's where we need to focus on here. We need to make the creation of those cookie cutters extremely quick and streamlined. So we need to automate the creation of those service patterns and the code that is used within those. We need to remove most, if not all, of the human interaction, because whenever the human is involved, it slows things down and increases costs. So these tools do require some initial investment in that tooling, but once the tools are in place, and we're going to show you that they can be used to spin up many different patterns very quickly. So let's start to break things down. So the first thing we talked about is the creation of NSDs. So the NSD definitions is you can go into the NSO command line and create those NSDs quite easily, but it can be time consuming and lead to errors. So out of the box, there are some NSD editor GUIs with the NFVO package that help you sort of drag and drop things onto a canvas and build up your NSD with VNFs and virtual links between those VNFs. Also, what we've done with ours is develop some custom tools on top of the framework. And they help us in a couple of different ways, because they help us with firstly was requirements gathering. So it's one of those blocks in the Gantt chart that we were showing earlier that does consume a lot of time in the whole process. So we're now taking the requirements gathering into a spreadsheet, into a well-defined set of requirements now. So we have a spreadsheet with like 3 tabs on it. One for the physical connectivities where the customer can add what they're looking for there. One for the virtual elements in that pattern. And then finally, the virtual links that are going to be defined that link those things together. So everything is pushed into that spreadsheet. There's also some other information that we can gather in there about IP mask lengths that are needed for the different links, etc. Once that's in a spreadsheet, the The data's there. That's the input we get from the customer. That's the point where we have the human interaction. After that, we don't need any human interaction because we can run Python scripts that parse that spreadsheet and transform it into an NFD. And all that's possible thanks to this NSO data model, the standardization of the NFD into this Etsimano standard. So once we create those NFDs from that spreadsheet, we can also create topology views as well. So this makes it really good for the customer to view those requirements. So before we even start developing the pattern and testing it and putting it into any environment, we can show the customer what it looks like. So we can show, the virtual elements. You can see the connection, the virtual connections in that topology. So it's now really easy for the customer to view the requirements they've asked for in that spreadsheet, and they can view it in a nice topology, and so they can spot any sorts of issues. So the key callouts here are, requirements gathering is now very standardized. It's limited to those three elements that we talked about, but it's flexible enough that they can have any combination of VNFs and PNFs, and they can use it to string together those devices. And it allows us to visualize that topology as well, for the customer to visualize to make sure it looks good and they're happy. So time to gather requirements is now hours rather than days because of these tools. So the next step, once we've defined our models, the next step is about the coding. So in NSO, generally we have to develop templates for different devices. So we talked about earlier about narrowing the scope. So we're definitely narrowing the scope here, and we're talking about just making sure that these services can spin up the devices in the service chain and can apply a day 0 and a day 1 configuration on top of that. That means that the pattern is, you can traverse the pattern, all the elements can talk to each other. A basic configuration is applied to those devices. Any day 2 services is extracted into a different day 2 model, so a different day 2 service, and that can either be done automatically with NSO models again, or could be done manually if those day 2 services can't be standardized. So we have that option at this point. So what did we do with our customer example? So what we did was we agreed a set of standard configurations for day 0, day 1 with the customer. So for each possible device in the service chain, we would agree a standard set of configuration items, and we would store that into a golden template. So that would all be pushed into a golden template. So say a FortiGate firewall device would have a golden template. For that, we'd have a CSR golden template, a F5 golden template. So it'd all be stored in this golden template. And then we have an action in NSO that reads from that golden template and matches that with the NFD that we'd find. So it parses the NFD, reads from the golden template, and creates a template for that particular service. And it does this by substituting the use case specific details from the NFD into the golden templates to create a more dynamic template. And this is needed because our services can be defined differently. So if I go back to this model here, you'll see that the load balancer, for example, this load balancer here in this VNF, it has a different number of VNICs, virtual network interface connections. So it has a northbound to the CSR, it has a southbound that goes to some firewalls, say perhaps. It has some peer links, it has a connection to HSN, has a connection to maybe a Splunk server. So it's dynamic. So it's, depending on how I define my model, that VNF has different number of VNICs on it. So we have to ensure that our tool that we're developing is able to handle those VNICs. So what it did was it took the definition, looked at all the VNICs that are defined there, and then dynamically added to the template configuration needed for each one of those interfaces. So it was really good at handling that. So once we've got those templates, so we've got an action that takes the NSD, takes some golden configs, and generates some templates. So now we have everything we need. We have our service model, our NSD, we have our templates. We now can deploy this into our environments. Again, we can use some tools to do this. We've got you know, a CI/CD pipeline, and we can use things like Jenkins and Artifactory to push those generated elements out to the environments very quickly. So the key callouts here, we can see we've got a rapid movement from our requirements gathering to now coding those templates. So we can do all that automatically just with an action on our in NSO. It's all based on well-defined set of agreed standards with the customer, so they know exactly what is being spun up. So every time a virtual element is spun up, they know that a very well-defined set of standards is being applied to those VNFs. We also then make sure that we can show that the rapid deployment into our different environments. So if we want to deploy this into a test environment, into a production environment, we have CI/CD, you know, a pipeline to do that. This all means that the time to develop templates and code is now done in minutes instead of perhaps days. So the last sort of piece of the puzzle is about automated testing. So we've got our design, we've got our development, we've now can spin up patterns, we can now spin up instances of our services. We want to test, obviously, these services to make sure that, you know, everything's looking good. What we've chosen to use is the Fiesta toolset. It's a new set of Cisco test automation libraries built around the robot framework. And there are specific libraries for NSO that enable us to really easily integrate with NSO and the NFV framework to query those data models. So we talked about why NSO is so powerful in for this automation piece, is because everything is based on a data model. So we can easily query those data models, and we can dynamically generate test cases as well. And we can do this, you know, using these robot scripts. They utilize quite simple sort of language. It's not complex programming. It uses sort of keywords to help us create test cases. Brief slide about the architecture. I won't go into this too much. I mean, we can definitely share some more details about the Fiesta architecture, but generally it's all about defining those test cases that then have some libraries that then can query our different systems and create tests for those. Thing to mention here as well is that you know, we have to have some trade-offs. So the aim that we've talked about throughout this whole presentation is rapid development of new services. It does mean that some of the testing, you know, we have to have some trade-offs here, that we have to balance the rapid agility with a sort of pure, perfect testing methodology. So what we've done in our trade-off is to base some of the test cases off the model that's been defined in NSO. So parsing the NSD that's been defined for this service, for example. So I know it's not the perfect way of testing, so you shouldn't really ever write test cases from something that you've written, right? The code that you've written. But all we're saying is, as long as the NSD has been defined correctly, it's okay that you know, our test cases can drive dynamically from that NSD to build a dynamic test case. So slight trade-off, and it's worth sort of bearing that in mind on this. So how does this all work? So the Fiesta tool allows us to code, put code in that can go through those NSD models, those instances of NSDs, and loop through them. So there's the Fiesta tools enable you to loop through things and to be able to, you know, for each element inside that definition to make sure that, you know, everything is, sorry, to create a new test case. So, you know, you parse the NSD, you find a VNF, so you write a test case that says, okay, for my VNF, perhaps ping my neighbors, for example. Right, move on to the next element. Okay, you know, new test now that pings this element, pings its neighbor. So you can build up your test cases dynamically in this way. In our customer example, we had sort of three main, we were able to sort of create dynamic tests for three main areas. First one was connectivity. So we would loop through the NSD, and each element in there we would test, communicate. It could communicate with its neighbors. So we have these virtual elements that was spun up, and also we had some ACI fabric to connect the elements together, and that was all configured using NSO and NFV, and we would make sure that each one of those elements could ping its neighbors. So that would then show you have full end-to-end connectivity within your pattern, and you do that dynamically. Naming conventions was another one we were able to do. So once the service was spun up, we would parse that live status, the live data in NSO, and we would make sure that any elements that were spun up adhered to the naming conventions that this enterprise customer were quite strict about ensuring. And the last one we were doing was about parsing the live status of the devices that we were spinning up and the touching, and making sure that the configuration that we were applying in our day one models was according to the standards that have been defined by the customer. So we were able to spin up those test cases dynamically just by parsing that NSC. We didn't need any human interaction at this point. And obviously the output from the Fiesta library is a nice HTML report that allows us to sort of drill down into the the test cases that perhaps failed. So in this case, you can see you've got some three areas: the naming convention, the NARES, the configuration testing, and the connectivity test. You can see there's been a failure in the connectivity test. So you can drill down. You can see that okay, the F5 load balancer couldn't ping the VPX, the VPX device, and there was an issue there with connectivity. So easy enough now. I can see where the problem is, and I can go and fix that either in the model or in the code, in the template. So I think we can see that we've got a great reusable testing framework here that we can use to dynamically create tests off a model, off this NSO data model, and we can then produce easy to use, easy to read reports from the results. So it's really good to highlight here that time to create and execute tests in our case was reduced from weeks where we were doing it manually and having people go into devices to review config and ping other devices. That was all reduced from weeks to minutes. These tests could now run in under 20 minutes. It was a massive saving for our project. So the last consideration, once we've got our services up and tested and deployed, is operationally how do you manage that service. So NSO gives you one data store, one store for service models, device models, and you can have that correlation between them. So it's an awesome place to be able to query your services, your instances of your services, and you get all the details you need. Resource modeling as well. NSO can give you the IPAM resources and VLAN management, things like that. So you can easily model all that within NSO, have it all in one place. It means things like reporting is so much easier. You just query one data source to get all these different elements that you need. And obviously with NSO, you get things like redeployments and deletions for free as well. So it's all things to consider. So back to our initial question is it viable to have end-to-end automation for a service pattern that's used infrequently or just once? Well, I hope we've shown with NSO, with NFV, and the Fiesta tools library that we can do this. We can reduce that time to deliver. So we can baseline our requirements, and then we can create tools to create things like the templates, the automation of the testing, and we can run everything from that automatically. Obviously, this impacts the cost. The time to market of these patterns is now hours, if sometimes minutes, really, to get these things spun up now. The quality is also increased. I mean, you may not think, you may have to have some trade-offs here, but the trade-off we've taken is to reduce the complexity of these patterns. So it means that we can standardize things and automate things and it makes the quality much, much better. And we saw this as well with our customer that, you know, we were having many, many cycles of developing and testing and going back and forth. That was reduced, you know, until we would never leave the development environment until we had a successful run through of all our tests. So it was, you know, it was really powerful to do that. And lastly, it also meant that the changes that once we had those service patterns spun up, changes were much easier. You know, you could just go into the requirements spreadsheet, change a VNF here or a virtual link here or an IP address, and regenerate everything again. So it was great to be able to do that as well. So our customer, historically, as I said, we were looking at a timeline of weeks to get these patterns developed. But, you know, we slowly moved to, you know, simplifying the requirements gathering. Once we had that simplified, we saved lots of time. We then auto-generated sort of NFCs, and that saved us a lot more time as well. And then finally, we moved to the point where we automated almost everything, you know, apart from those initial inputs from the customer and requirements. Everything else was just auto-generated in a production line, and we were stamping out those cookie cutters really quickly, so we could make a cookie cutter. That cookie cutter could be, you know, make one cookie, move on to the next cookie cutter, and we can make that all within hours or days. It's really helped in the recent coronavirus, the COVID-19 crisis, where the customer had to lean really heavily on our tools because, you know, they had to rapidly move their business. A lot more of their colleagues, the employees, had to work from home, and suddenly you had a massive demand on the remote access services. So there was a big requirement that came in. They asked us to help out there, so we were able to really rapidly define a new service model for a remote access service, connect the campus to the internet, so the customer and, you know, colleagues could log in, and we were able to spin that up within a day or so and get it onto production really, really quickly. So it really shined through the work that we did there. It really helped that customer deploy those services very, very quickly. So just to review, how is all this possible? Well, I think I've tried to enforce this along the way, but the data model driven service design that NSO gives you is so powerful here. It allows us to build on top of that because we know what we're doing. It's, you know, there's a data model defined for this service, and we know how to define that, and therefore, you know, so everything's driven from that. The templates as well means, you know, the NSO uses these templates means we can define standards, and we can reuse those templates in all our, you know, cookie cutters that we're creating. And also with NSO, you get that live view of the device configuration, so that view of what's in the network, and it allows our testing tools to reliably query that data as well. So final consideration, just want to touch on, because I know enterprise customers, obviously there is a strong push towards sort of using Ansible for some of this sort of stuff. And as I say, with Ansible, it's great for some things, but if you wanted to, you know, define these sorts of services, it's a procedural language, right? So you'd have to define it step by step, exactly how you would spin up the different parts of that service chain, and you would have to write it in a sort of long procedural configuration. That's very hard to automate. So to try and automate something, or to create something procedurally, is very, very difficult. It's much easier if you have a model and you have this fast map that, you know, the NSO employs, that you can define a model and then the NSO does the, you know, gets to the end state for you. It does all that for you, and it means we can build those tools much easily to do it. So yeah, I think Ansible, you know, it can be very good for quickly spinning up some services, but then if you're going to be doing this again and again and again, I believe that, you know, NSO's advantage here is that because it has this data model driven approach, you can invest in some tools that can make that you know, make that creation of those data models much quicker. Okay, thank you very much for listening. hopefully you've got some questions.